When we think about our relationship between humans and technology, we always have the impression that we are the masters of the game. Like we are the ones who push the technology, right? We are the ones who made the cloud and quantum and GenAI. Occasionally we also make funny things like blockchains, but that's okay, right? But fundamentally we think we are the ones pushing the technology forward. But the interesting part is the technology also pushes back. If we make something, if we push technology to its limits, but it exceeds our own limits, like it's hard to comprehend, it's difficult to work with, it's easy to make mistakes, then we become the limiting element. And interestingly, in recent years, we actually made it a little bit worse for ourselves. Because we had the great idea that the software delivery process is fraught with friction, right? It's like somebody writes the requirements and somebody else codes, somebody else tests, somebody accepts, somebody else operates. That is not very good. You have all these handovers. So we had the great idea. It's like, hey, isn't life going to be a lot easier if we shift this all left? We avoid all these handover points. Now, unfortunately, shifting left has become kind of piling left, right? Your average developer now should be a product owner, a business analyst, a domain-driven design specialist, a distributed systems designer, a security specialist, a operational specialist, and if they have any time left, they might also be writing a little bit of code. So the catch with this is, where are you going to find these people? And that's why words like cognitive load have become common vocabulary. Now, in our industry, we're never short of solutions, or at least the promise of a solution, and this is where generally platforms come into play. And we kind of call this game the buzzword bingo, right? It makes abstractions, it reduces the cognitive load, it has guardrails, but it doesn't limit us, it increases productivity, it does all these magical things, and we know what it's called, but we don't exactly know how it works, right? So it's a platform and it will solve everything. Now, what I want to do today is look a little bit inside the buzzword. It's a thing that as an architect I like to do, and then also see how this has a lot more to do with domain modeling than it might originally appear. Now, the idea of building a common layer isn't new at all, right? We don't build software from scratch. We have cloud frameworks, operating systems, libraries, right? There's a lot of common things that we have that we build on top of. Makes total sense. But the drivers tend to be slightly different. Generally, we see this from a cost argument, right? Building on top of a common layer is cheaper than building it from scratch. And the more often you use this common layer, then the better the economics of this are. It's the reuse argument, right? Very plausible. And if somebody wants to use the base layer but it's missing something, then, well, we sort of wait for the time where we put this into the base layer. Well, not so bad. But in a world where things are faster moving, the economies of speed, where it's all about productivity, the construct looks very similar, but the driver is a different one. Cost isn't the main driver, speed is the main driver. And that looks very similar, but in the end leads to different decisions. So for example, if you broad brush and you put everything on the same platform, on the left side, you would feel very good about yourself. On the right-hand side, if that thing sort of is the lowest common denominator, but it doesn't really serve anybody really well, you will not be happy because you slowed people down, you didn't increase their productivity. So on the right-hand side, in economies of speed, you might prefer smaller, opinionated things. Because also you're living in a world of change, so if everybody depends on your base layer, now you get a little bit nervous about your abstractions and how well your abstractions hold, and if you need to make a change, right, you have 10,000 people depending on this, so you're much more thinking about the dynamic, and suddenly becoming smaller and nimble looks a lot more appealing than it does on the left-hand side. So these small nuances actually make us make the inverse decisions. So drawing a picture, and I always joke that in my book this is the ugliest but in the end still the most meaningful picture, is that classic sort of economies of scale software delivery kind of looks like this pyramid. And I've been chief architect for many years, so I see IT strategy documents always follow this pyramid because the economics just look amazing. You have this base layer, and when you enter a new market or new line of business, or you need to white label something, all you need to do is do that little bit, put the cherry on the cake that's already baked, right? And then you have a different kind of product, very appealing. Now, I always tell people this is a bit of a warning signal because in real life we stopped building pyramids like 5,000 years ago, right? But in IT, we're still like, hey, this is the greatest thing. So we're like, we should think a little bit whether that is actually the case. Now, as architects, when we see something like this, we ask a very important question. And the question is always, what assumptions are baked into this model? If we don't ask so much, does it work? Because probably it does, otherwise people wouldn't come up with it. But we ask about when does it work? In which context, under which circumstances does it work? Like what are the assumptions that have to be given in order for this to work? And here is a very important assumption that is baked in. I can do this only if I can anticipate everyone's needs. Because that's the only way I can put the little cherry, because I knew exactly they want the green, blue, or red cherry, right? I made my cake so they can do this. I can only do this if I can anticipate the needs. Now that comes with some problems. The one is, you have to be pretty smart to anticipate everybody's needs. I probably wouldn't claim that I can do that, but there's a bigger problem. I don't want to anticipate everybody's needs. I want innovation, right? I want people to do things that I didn't think about, right? This whole idea that there's a group of people who anticipated everything and then everybody else does what they already anticipated, I don't think that is how innovation functions. You want people to do things that you did not anticipate. So the goal of a platform is not to narrow the playing field. The goal of the platform is to widen the playing field. You want to improve the economics of innovation and diversity. You want more stuff on top, not less. That's why I say ugly picture, but it captures really the big difference, and it also captures where a lot of in-house platform projects go wrong, because the developers think they're getting the thing on the right, and infrastructure and operations is really in love with the thing on the left, and that does not mix very well. So they're fundamentally different. Back to our buzzword bingo. Because they're fundamentally different, they can do some magic things, but only if we understand how they are so different. Now, another weakness we have as software people is we always believe we invented everything, right? Because we make new stuff all the time, so we always believe we're like on the frontier of everything, and we kind of don't have much of a rear view mirror because we don't need. Well, in this case, we should have a rear view mirror, and app metaphor, because I'm a bit famous for car metaphors, right? The car industry has had enormous success with platforms for more than half a century. And what they learned is they live in a world where they need heavy base engineering, right? Fancy transmissions, emission control systems, anti-lock brakes, well, then electric cars, charging systems, right? That stuff is not cheap. But they want to have many different models for many different customer segments. That doesn't mix really well. So the idea was, can I get economies of scale at the bottom, like capitalize on my core investment, but same as before, have more diversity on top? I once attended a super interesting talk. Was a gentleman who did consulting with BMW over decades, and he explained this very easily. He said, when we were young, BMW had 3 models, 3, 5, and 7 series. All very nice cars, but that was it. How many models does BMW have today? Right? It's like 30 or something. It's like 1, 2, 3, 4, 5, 6, 7 at least. X1 to M1, i4, 8, Mini, you count. It's probably like, it's more than 2 dozen. It's about 30. So his answer was very easy. That would not be possible without a platform strategy, right? You cannot have 30 car models if you don't have this kind of way of building things. So even the folks who deal with like sheet metal and stuff have shown that they can have more diversity on top of a common base. So if they can do it with bolts and screws and sheet metal, probably we can do this with bits and bytes. And the amazing thing, in the end, it drives innovation on both sides because you have the scale economics underneath. That's why you can build fancy technology like the cloud providers do. A cloud is a scale business, right? Try to become a hyperscaler. A little bit expensive, right? A couple billion per data center, global fiber networks. You need to build things like globally distributed transactional databases, right? That stuff doesn't come cheap. So you want the scale economics underneath, but the magic of the cloud is it doesn't pass on the scale economics to you. You get the server for $1 per hour. You don't feel the scale. You live in speed economics. And that's the magic of the platform. On top, you have the speed economics, the diversity and the rapid innovation. And underneath, you have the scale economics. And if you get that right, that is enormously powerful because you advance on both levels. Coming back to the cars, things like sequential gearboxes would not be possible without this because doing it for one car model would be far too expensive. Yes, you want the model, yet you want the model diversity because you want to reach different customer and price segments. So, and as I said, if they can do this with cars, we can probably do this with software. Now, I like simple tests because all this makes sense, but it's a little bit abstract, right? So how do you make this easy to test? Is this thing that you call platform really a platform? Because we have an old joke, it's like, why does everybody build a platform? Because platform is a good word to get a project funded. Well, now it's GenAI, right? That's what you call things to get your project funded. So everything is kind of a platform. But we want a more real test about, hey, is this thing I built just another common services layer, or is this actually a platform? So here's a great test. If people have built something that you did not anticipate, that is good. That is actually a mark of a platform. When I built an in-house developer platform for the government of Singapore, we found one such case. We did basically like a CI/CD platform is where we started, right? Software delivery thing. So we found one project which did a lot of software delivery. They seem to be our best customer. They push stuff out to their servers like all the time, like dozens of times a day. We're like, oh, they are the showcase customers of rapid feature delivery. What turned out? They used our pipeline for data distribution. They were not actually pushing any code. They were replicating data on our platform because you could do that. You just called it an artifact and you just pushed it out. And we're like, well, that wasn't exactly what we had in mind, but it passed the test, right? They could do something we did not anticipate, and that means we left the top of the pyramid wide open, and in the end we had to say, that is a great thing. That means it's a platform. Coming back to the cars, this double pyramid is very important. What happens, and the car manufacturers have tested this for us, is it's always tempting to slip back into the left picture because the double pyramid means you're building a lot of stuff on top still, and that costs money. So you're always tempted to like, can I make that piece on the top smaller because the economics, the economies of scale get better. This is a dangerous and slippery slope. Now, luckily, the car manufacturers validated this for us about in the 1980s, where Cadillac made a car called the Cadillac Cimarron. Horrible car, nobody remembers except for the so-called Cadillac Cimarron effect. You can read up on it. And they had this ingenious idea that instead of making a new car on top of the platform, it is much cheaper to take an existing car model, put all the options in, so you put power windows, nice stereo, automatic transmission, big engine, right, nice metallic paint, and then you call this thing a Cadillac. So they took a Chevy Cavalier, decked it all out, and say, this is now a Cadillac. Now, as you can imagine, the people went like, hold on, this is no Cadillac, this is like a Chevy Cavalier, and I'm not paying a Cadillac price. And it was a giant failure. Because what they did is they tried to make the top, the inverse part of the pyramid so small that they essentially slipped back into the left-hand side model, and that did not work. There was no innovation, there was no differentiator on top. So this is one of the forces you need to resist. The temptation will always be there to say, oh, why do people have to build on top? Can't this be like no code? Can't they just configure? And then you slip back into the left model. You want the stuff on top because that's where the innovation happens. That's where the stuff happens that you did not anticipate. So resist the urge to want to shrink that. That is vitally important to the concept of a platform. Now, bringing this into an organization, there's one big challenge. If you draw what a platform looks like, it looks awfully like the stuff that you had before, right? Somebody builds applications, and underneath there's another layer which in one case sort of operates the applications, sort of build and run kind of the old model, but admittedly the platform looks kind of the same, and you're like, oh, this isn't particularly helpful. Now, it doesn't mean platforms don't help, it means this model is wrong. You cannot use a structural model to think about economies of speed. Economies of speed deal with change, uncertainty, speed, movement, right? So a structural model doesn't display those things, so that's why you shouldn't be surprised that this actually doesn't work. You need a dynamic model, because that's the only way you can express change and speed and uncertainty. And once you put the software development cycle on here, like inner loop and outer loop, we like to call it, right? Where you build something, you put it in production, you see how it works, both from a technical perspective, like is it reliable, does it run, is it performant, as well as from a business perspective, right? Are these the features that the users wanted, right? If you draw that cycle on the left-hand side, you can easily see the friction points, right? You have this throw it over the wall and throw it back kind of thing. So a apt picture is that the platform team cannot be in the cycle. When I used to work for AWS for quite a few years, if anybody deploys a Lambda function, nobody at AWS does anything. Well, hopefully not, right? Because with the billions of deploys a day, this would be ludicrous. So as a platform team, if you find yourself in the cycle, initially it may be needed because you're helping people, but it's always a little warning sign. You should not be in this cycle because you become a bottleneck, you add friction. You are the bearing, the grease, the axle, whatever metaphor you want to use. You are the thing in the middle that makes this cycle spin faster, but you are not in this cycle. And this picture shows the difference very clearly. Right? This is not about filing a ticket and somebody else does something for you. It's not some fancy self-service portal. In the end, there's a manual process or another team, or somebody shows you how to do it, or somebody needs to get the license for you. That is all left model. That is not what platforms do. Platforms are self-service, fast, and nobody else is in this cycle. You get transparency and you get full control, even though you're using other people's software. So here it's very clear. Hey, now my clicker clicks for all the stuff that I didn't click. Hold on, I need to see where I am. Okay, here we are. Guardrails. Huh? Anybody heard the term guardrails? I'm pretty sure, right? When we platforms, people love guardrails. Well, I also love guardrails to be there, but I don't like to hit guardrails, right? Nobody kind of likes to do that. So what I say is the first thing when we want low friction, like we just saw, is we don't want guardrails, we want railways. And we're right next, the station is like right there, or there, I think, right? The railway doesn't stay on track because of the flange. The flange is like sort of the big part of the wheel, right, that you see sort of on the inside. That again is just for emergency tight turns, and so things don't derail. The railroad stays on track and can make turns because the wheels have this conical shape. I lived in Japan many years, learned this at the Railway Museum in Japan. They had differently shaped wheels, and you could try it yourself. And lo and behold, if the wheels are not shaped like this and connected to a rigid axle, the thing just goes straight off the track. So it's a low friction, self-centering mechanism. right? It keeps itself on track. It doesn't hit the guardrails. And that's what you want. And the amazing thing is this invention is like, I don't know, 150 years old or something, and we still use it for high-speed trains. They go 300, 350 kilometers an hour because it is low friction. So this is what you want. You want things to be self-centering and have the guardrails just for emergency. If you prefer car metaphors over train metaphors, you can use this slogan. It's basically wherever there's a guardrail, you also want lane assist. The guardrail is there to not be hit. It's an emergency device, not a steering device. Nobody follows the road by scraping along the guardrail, right? It'd be super foolish. So it's for emergency only. So when you hit the guardrail, you're happy because you didn't go down the cliff, but you're also unhappy because your car is wrecked and your guardrail is wrecked. And I do see this go wrong with many platform projects where we were promised the thing on the left. They say, oh, golden path, super highway, right? You're going to move like infinite speed, and yeah, we're going to put some guardrails, whatever, right? But, you know, you're going to be highly productive. And in the end, what you get is the thing on the right where people build giant guardrails, and then they ran out of money for the pavement, right? And the happy path is not that golden. It's rather a little bit muddy, right? But the guardrails are fantastically high. This is not good for developer productivity, right? And this does happen. I've seen this multiple times. So you want railroad wheels or lane assist. You want rapid feedback for the teams. You want them to be self-centering. If you're worried about cloud costs, the best way to do is you give transparency to the teams. If they deploy something, they see the costs go up and down, right? They can decide if this is the day before the launch, maybe they launch first and fix later, right? If they have time, they invest in cost reduction, right? They are self-centering, but for that they need a feedback mechanism and they need the transparency. And the guardrail is only for absolute emergency. You know, if you get a denial of service attack or somebody does something really silly, that's where like the guardrail's kicking. But that should be the exception, not the norm. So you want lane assist. Well, so that's what we want to do. Now the question is, how do we do this, right? And remember the buzzword bingo is like, oh, we abstract the complexity of this underlying cloud something rather, right? So that we gain productivity, etc. So abstraction is a word we use relatively easily, often forgetting what is actually required to be able to legitimately call something an abstraction. And yet again, we learn from the automotive industry, engineers struggle with naming. We all struggle with naming. Let's admit it, naming is hard. And one of the reasons naming is so hard because we are the people who build all these complicated pieces. So we just want people to know how complicated they were. And all this good stuff is in there. It's understandable. I do this. When Bobby and I wrote enterprise integration patterns, we did exactly the same thing. The scatter-gather pattern was originally called broadcast aggregate. So we did exactly the same thing. I'm not here to say like, oh, if you do this, you're like not a great developer. I'm here to say this happens naturally, so watch out for it. Right? We called it broadcast aggregate because those were the two components that made up the pattern. It's the most logical thing to do. And then later on we came as like, oh, that's not a really useful name. So we renamed it to scatter-gather, which much more expresses the intent. So been there, done that. No preaching here, just speaking from experience. And yes, if the software engineers had named the automobile, right, it would be called piston, crankshaft, gear, wheel, assembly, factory, singleton, something rather, right? So luckily somebody was clever enough to say this is an automobile, right? It moves itself. And if you love complex systems theory and Russ Ackoff and those kind of people, you realize that the automobile, the self-moving property of this thing, is a property of the entire system. It is not the property of any single part, right? Only the car drives, no part of the car can drive. You can roll the wheel down the street, that doesn't count. The engine doesn't drive itself, right? Nothing drives itself. So it is, in the end, the appropriate name for the system as a whole because the system has different properties than the parts. You cannot describe the properties of the system by listing the ingredients, right? That's what we learn from very smart people who teach us about complex systems theory. The automobile only applies to the entire thing, and that's why it's a great name. And again, it's so easy to get this wrong because in North America, what do people call this pedal on the right? We call that gas pedal. Now, if you have an electric vehicle, as you should, that is probably not having any gas in the batteries or anywhere else, so that is a leaky abstraction, right? This should be properly called the accelerator. There we go. It's called the accelerator. It makes the car go faster. Naming does matter, and little nuances do matter. I was chatting with Eric Evans yesterday, and we sort of jokingly a little bit saying we're both people who like to tease out the little things who turn out to be not so little. Right? This seems like a trivial difference, but it's not trivial. And we here at a DDD conference, it is all about this, right? It's getting the little things right, then the end makes a big difference. And abstraction, of course, has a ton to do with that. Now, when people start building platforms, they often build them on top of the cloud. Routinely they do. And the first thing they do is they make sane defaults. They take some settings out to make this easier. Now, careful, it's well-intentioned, but it often backfires. And the analogy I use is, you give the kids a puzzle, a jigsaw puzzle of 1,000 pieces, and it's a little bit difficult. Taking 100 pieces out is not going to make it easier. It actually makes it harder. Because all these cloud settings, they have interrelationships. They're not orthogonal. They, in fact, cost, they impact latency, they impact other things. So if you just hide them away, you're not reducing the cognitive load. You're building a little bit more of an illusion. You're saying, oh, this is all easy, don't worry, until you have to worry, right? That's what we call tricking people. They don't like to be tricked. So you can't just take pieces out and claim that reduce cognitive load. You run the risk of having created an illusion. You say, oh, this is all easy. And at AWS, we argued a lot about this. People said, oh, it's got to be simple. I'm like, this is an asynchronous event-driven distributed system. That is not simple. Right? It's just like it isn't. It has an inherent complexity, and you gotta express that. And people say, no, we want to make this simple. And we argued a lot about this, which means it's not easy to do, but ultimately essential. Because if you omit too much stuff, you end up creating illusions. You set expectations that don't hold. And one of my favorite examples, I always have to backtrack a little bit because the world of architecture is never sort of left or right or black or white kind of thing, but a remote procedure call runs the risk of being an illusion. Now, these days we have gRPC and other cool stuff, so we made a lot of progress, but fundamentally the notion of calling something remote procedure call is a very dangerous proposition. A remote procedure call is nothing like a local procedure call, right? It has no call stack. It has long latency. It has failure modes. It has distributed state and inconsistent states. You all know the 8 fallacies of distributed computing, right? It has a million properties that a local procedure call doesn't have, so it is not a procedure call. So this is where the abstraction has gone too high, where people say, look, you just need to call this method, right? And don't worry about it. And I had this firsthand many, many years ago when I worked at Google, right? Somebody called a method in a loop, and we called this method happily 1,000 times. Well, under the covers, you found out that method was making a remote call. Didn't perform exactly that stellar, right? And this is then the end where distributed tracing and YAG and all the other things came from. So you find out that that doesn't work. You know, the abstraction did not hold. So it's a bit of a Goldilocks game, right? You want your soup not too cold, not too hot kind of thing, right? If you don't abstract anything, don't call it gas pedal, right? Because that doesn't abstract anything away. But also don't make your car sort of like, oh, don't worry about anything. Well, I guess self-driving cars maybe can do this, but our software not quite yet. So it's a Goldilocks kind of thing, right? And I don't have a great recipe for saying, oh, this is how you land smack center. For me, almost all of these things are calibration exercises. They're all based on feedback. You do a little bit, you see how it goes, you compensate. It's like steering down the road, right? You don't sit at home and calculate when you have to turn the wheel to make a left turn. You see the left turn coming, and you steer when the turn comes. It's all based, the real world is almost all based on feedback cycles, right? I want to touch this thing. I don't calculate like the angles of my arms till my finger hits. No, I move my finger until it hits this thing. The real world is all based on feedback cycles, and that is largely true for this as well. Ironically, in a large organization, sometimes we consider this like inferior. It's like, oh, can't we think this through and plan this all out? Can't we be smart to figure this out? I'm like, some problems are not made to be planned out. Rapid feedback is how the whole world functions, served us well for billions of years, nothing wrong with it, right? It's not inferior in many cases, it is the only approach that works. Everything else becomes an illusion. It's my old joke when I worked in insurance, right? We made giant project plans, and when reality wouldn't match the plan, what did we do? Well, we blamed reality, right? It just wasn't playing along with our perfect plans. Not such a clever setup, right? In the end, you need feedback cycles. The software is done when the software is done. So coming back to the abstraction, we always feel when we abstract something, we take things away. And we do. Right? Because if everything is still there, you obviously haven't abstracted anything. So we might be tempted to feel that when we take things away, we see less because something is missing. But it's actually the opposite that works. You amplify. By omitting some things, you amplify others. Now, your judgment is which things are worth amplifying. And this comes back to the asynchronous event-driven distributed system thing, right? I like to amplify things like back pressure and time to live and flow management, right? Because I know the inherent, so I want to amplify those. Other people didn't want to amplify those, right? So you make a judgment call, but the answer is by omitting things, by showing less, you actually show more. People see things that they otherwise would not see. They can now see the forest, not just the trees. It's a delicate exercise, but don't be shy, right? Taking some things out doesn't mean you're not giving people the whole story. It means you're sort of amplifying, the things that really matter to them. It works both directions. So this has a important implication. Coming back to our ugly pyramid, we are often tempted that the narrower we can make it, the more complex tech we're hiding, right? So we might be saying, isn't the right platform better than the left platform? And I would say cautious, right? You might really understand your domain really well and you find fantastic abstractions over time, and that would be a good thing because you're going to the right, you have a more precise, leaner model, but that takes a lot of effort. So it doesn't mean the right is necessarily better than the left. The right takes a lot of effort to get right. So sometimes people rush it to make it narrow, and in the end, you hide more things, and the size of the interface does not equal the cognitive load. The cognitive load is not measured by the number of methods or parameters. That is a big fallacy. And I have a real-life example from many, many, many years ago when I wrote a chapter for the book 37 Things Every Programmer Should Know, where somebody overloaded the meaning of one parameter. And it wasn't quite as extreme as this. I kind of amplified this, but basically, hey, I got this string parameter, and all you need to do is pass this one parameter. It can either be a literal string, but if you put this clever ending in, then it actually reads from the file name. Isn't this really clever because it only has a single method, and I don't need a flag for whether it's a file name or string parameter? Isn't this fantastic? No, it is not fantastic, right? This is high cognitive load in a seemingly simple package. It's like the worst thing you can do. The cloud, unfortunately, is full of this. Somewhere there's a little bit of an integer parameter, there's a little bit of a string parameter, all looks pretty harmless, and then you read 20 pages of documentation to understand, that little parameter is the time to live setting on a queue that you didn't even know existed, right? Happens, real world, no names mentioned, right? And then you realize, wow, this little integer parameter has a long, long, long story to it, and the cognitive load is high because you need to understand the runtime behavior of the system, and the fact that this became a single integer doesn't help you at all. If anything, it deprived you of the type system. So my old joke is if you do serverless development in the cloud, it's basically 2 integers, 1 string, and 30 pages of documentation. Now, which developer loves reading documentation, right? So this is actually the stuff I worked on at AWS to make the type system more reflective of the runtime behavior of the services. So narrow interface not equals cognitive load. This can go completely the opposite. Ironically, The bad ideas in IT, we always have time and again, because this idea we already had in the old days with mainframe systems and databases, where it was very difficult to add a database field. And in the 70s, and that's where things come, oh, if the last name starts with X, then it's actually the last name, and if it starts with a space, then it's actually the full name, like these really record kind of things, because we couldn't make another field, so we overloaded it, and we call that legacy. So let's not do this with modern software and saying, hey, all you need is like, you set this integer and a little bit of a string, and everything will be fine. That is not low cognitive load. So one of my mantras here is, it's not about simple. Some things have inherent complexity, right? Making them simpler than they generally are works against you, not for you, right? You want to get rid of accidental complexity, but there's an inherent complexity that they have. So you want to make it intuitive. You want to guide the user. You want to show them how this works. You want to guide the person, but you don't want to create an illusion. Now, this is a very slippery slope for platform builders, and that is the platform will grow in capability by itself. People always like, oh, I could use your platform if it only did this thing, right? So the gravity field is always more completeness, more capability. Enterprises use capability maps. You evaluate a product. You look at the capabilities. Does it do what I need? We over-index on capability. If you want the double pyramid, if you want platform, speed, independence, all the kind of things, low cost of innovation, you need composability. You need to make it easy to put pieces together, right? And you need it to be cohesive so the whole thing makes sense. Well, that is much harder to do. So as a platform team, I always warn, the stuff at the bottom, that's going to come by itself. You don't need to do anything, but you need to counter steer against the top. Cloud providers are great examples of this. There's a famous cloud provider who always bragged about, oh, we have more services in production than anybody else. You can guess who that was. Well, like about a year ago or so, they stopped saying this because they also learned it's not about having more services. It is about how easy they are to put together. I always say you can read a lot between the lines in those marketing messages, right, if you listen carefully, so they teach us something. So, abstractions, right? Goldilocks. Yeah, we want to not simplify or stupefy things. We want to express the inherent complexity, right? Is the subtitle of Eric Evans' book, right? We tackle the complexity. It doesn't say make the complexity go away, right? You tackle it, you express it, you expose it so it's intuitive to deal with it, but it doesn't necessarily have to be easy. Domain-driven design is not easy, right? But it makes things intuitive. So what does the domain look like that platform teams work in? So this is what I tell people. If you want to make a really powerful platform, build services that the cloud providers that you build on top of fundamentally cannot deliver. And you're like, oh, great, clever advice, dude. Like, they got billions of dollars and, like 10,000 developers. How I am going to build something that they cannot build? Well, you have one advantage. They need to build for the entire world because they are heavy scale economics. You only need to build for your organization and your domain. So understanding your domain is the ticket to building a really good platform. What you don't want to do is you don't want to take a cloud service and take 5 settings out and you say, oh, there was DynamoDB and my platform gives you a less capable DynamoDB because I fixed some settings. Like, that is not a really good seller. So we can again look in the rearview mirror. History, operating systems. Operating systems didn't reduce cognitive load by defaulting the drive letter for reading disk sectors from the disk. That would have been not that interesting. And this is what a sane default will be, right? Oh, a sane default is like, drive 0 is probably what you want, so you don't need to set the drive letter. Convenient maybe, abstraction, no. So operating systems are platforms. I had a fun podcast with Dave Farley where I said, oh, this platform garbage, right? Isn't that all the same old crap like operating systems? I'm like, well, the same ideas like operating systems. Also careful, the interval between us building massive platforms tends to be like 30, 40 years, like the operating system, the cloud, right? So it doesn't fall in our lap. But what an operating system did is layered a completely new vocabulary on top. Most of us don't read disk sectors or network packets unless you have a specialty thing that you're doing. You read streams, you have files, you have symbolic links, right? It defined a different language, right? You cannot have an abstraction if you use the same language from underneath, by definition. You know, I caught another famous cloud provider said, oh, here's the solution patterns which abstract some of the details. What is the first solution pattern called? Lambda SQS lambda. I'm like, well, you know, if you don't know what your lambda and SQS is, this is probably not really helping you. This is maybe a composition, but it surely is not an abstraction, right? That's like gas pedal, or that's like piston crankshaft gear wheel assembly, right? It's like, cannot work. So you need to do something more like this. Where do you go and look? Well, you look in your business domain because that is unique to you. So underneath, you might have a managed database. And again, small things matter. So if you can offer a database to your developers, and one is suitable for PII, personally identifiable information like customer data, and the other one is suitable as long as you don't have customer data. The one is cheap, the other one is expensive. They get to have a choice. This is powerful. This is not trivial. You translate it. This has regulatory stuff, reputation risk, internal processes, governance, right? There's a lot of stuff that needs to be put in there. And the cloud providers can give you the bells and whistles to make this, but they never make you this database. This is your database for your customer data configured to your needs, right? And some of that is with defaults, but the purpose is different, right? This is accelerator, not gas pedal, right? The purpose is customer data, no customer data, right? And you can easily see how you can come up with different things. You can have compute entities for certain kind of data, for certain classifications of applications, for different lines of business, right? You mix your business domain and the technical domain, and that's where you find the cool platform stuff that the cloud providers will never build because they're not in your domain. Another real example from an insurance customer, right? They made a ledger database, their financial services, so ledger means something to them. So ledger database is something that tracks all the changes, right? But it's not called like two databases with a sort of pipes thing in the middle, right? It's called ledger database. So you're looking at your domain, and the domain that you're really in is between your business domain, right? You have customer and ledger in your business domain, and you have managed database, you know, DynamoDB, Aurora, what they're all called in the different providers, right, underneath. And in between, you have a different domain language that pulls from both sides. Looks easy, not so easy to do, but this is where the magic is, right? This is value add. This is something the cloud provider cannot do for you, but it requires you to understand the technical domain because you got to understand what is PII and how do you get your database PII ready, but you also need to understand the business domain to say, does customer have PII data or not, or do I split this out of my domain model, right? You're living right in this intersection. Hence the title of my talk. Platform engineering is domain-driven design. That's the part you understand. Otherwise, you just end up with, you know, big guardrails and some little defaults kind of things. Few thoughts as takeaway to add on this. Abstractions we often think of as one way. And in the cloud, this particularly comes up. Let's say I layer something nice on top, and I say, ooh, I make a customer with PII, and I have an operational issue. Or let's take the ledger database as a better example, right? I wanted to make one ledger database, but in reality, I got 3 cloud services, right? And probably some add-ons, logging, other stuff, right? So how do I manage? I think I made one thing, but in reality, I made 3 resources, right? Or 4 or 5. How do I do? Well, again, we look in the rearview mirror. We often have the idea that compilers are entirely predictable and they only generate code that we didn't write. Of course, totally not true. Look at the Java compiler, right? You don't have a constructor, your bytecode does, right? And what does it do? So it's also not exactly what you write. You know, try some fancy things in Java and look at the bytecode. It's pretty interesting far away. Kotlin is probably even more interesting, right? So what you do is you have stack traces and line number tables. You link back into the model. This is also easily gone wrong in platforms. People make the abstraction, but they forget that if something goes wrong, something is slow, expensive, or breaks, it's hard to trace back where it comes from. Compilers showed us how to do this. Line numbers, you tag things with where they came from. So if something goes wrong at the low level, right, you get a stack trace or line number where the problem comes from. Can be done as long as you don't forget. And last footnote on this is, abstractions are fantastic, but they cannot abstract away physical properties. Right, and this has a lot to do, we see this a lot in cloud platforms and open source frameworks. Right, they say, oh, I want to be cloud neutral, right? And I make a queue, and sometimes the queue maps to SQS, and sometimes it maps to Google PubSub, and sometimes it maps to EventArc or whatever you have on Azure. Careful. Different service availability, different pricing models, different quotas, different latencies, right? There's a lot of physical properties that are different. Some of them have a time to live. The other ones don't have a time to live. Some of them deal with duplicates and retries differently. There's a lot of physical properties in these cloud services that your abstractions cannot and probably don't want to abstract away. So that would be another dangerous illusion. Like you cannot broad brush this. So be careful, right? The physical stuff is something is slow and expensive, right? With the abstraction, it's still largely slow and expensive. Joe Spolsky many years wrote the law of leaky abstractions, and most of his leaky examples are physical properties, latency, performance, cost, those kind of things, right? So know where your place is. You can do amazing things with logical abstractions, but it can't make all properties of the underlying system go away, and it probably should not. So that leaves me with only two things. It's not allowed to have a talk without mentioning GenAI, so we should think about this as well. And the question is, all this complexity of the base platform and all this abstraction, right? Isn't that problem going away? Because GenAI will just generate the code for me. So do I need to tease out this database with PII and all this, like Eric and I like to do, all the little things? Do I really need to deal with this? Because it'll just make the code for me. Well, I was clever enough and asked an LLM this very question. I say, hey, are you going to make the need for platform engineering and abstraction go away? And it answered itself, no, I'm not. So here we have the self-referential answer, right? Where it says, look, clear logical API structure, intuitive naming. You say, well, that is probably still on your end of the spectrum, right? This is not what GenAI does. It will help us do it, but it's not a replacement for us. So that's footnote number one. And I owe you the resolution of the magic impossible figure I had when I talked about illusions. That is actually real. Right, so always careful. Don't trust your eyes with everything. Right, it looks like an impossible figure because it's sort of inside out. It's really hard to see it for what it is, even when it's side by side. But I did not trick you. This thing is actually real. So I hope you enjoyed a little bit the journey, a little bit of cloud, platform engineering, and domain-driven design. And if you like this kind of stuff, there's a whole book about it that you can read. And because I like Belgium, the book is available at a discount. Only one important footnote, you can buy this in print from Amazon, but don't buy it from Amazon Belgium. Not because we don't like Amazon Belgium. There's some very strange thing going on where the book is not listed on the Amazon Belgium marketplace. So some third-party seller tries to sell this for like 80 freaking euros. And I think the book is very valuable, but I don't think you should be paying 80 euros, right? So get it from the Dutch or French or German marketplace. Dutch as a footnote if you want the print book. Also, I will stick around for much of the day, so you can always fetch me for free advice. I'm happy to chat to all of you. So thank you for listening. Enjoy the rest of the event.